Sorry. So today we continue from where we stopped yesterday. I believe that we stopped with this knowledge check yesterday. So we are in this session 1 of the third module, talking about functions and packages in R. So let me just go about this again. So suppose you create a function and want to load it in the workspace by sourcing the scripts containing the function. So which of the following R commands is used to look up the functions that are present in the workspace? So you want to see the functions you have created so far or the objects you have created so far. You can use the ls command to do that. That's why the ls command is the right answer to that. So also using arguments. So how do we use arguments in functions? So guidelines for specifying arguments in a function are listed below. So arguments are always named when you define a function. So you have a function. So you use the function keyword to create the function. So inside the function, you have parameters, that is arguments that you are going to put inside that function. You give it a name. So when you call a function, you do not have to specify the name. You do not have to specify the name of the argument. If you already know the position and the corresponding functions, the corresponding function of those parameters. So you don't have to say, okay, let's say a function takes two arguments, say x and y. You don't have to say, okay, you want to call that function, you have to say x is equal to this, y equals to this. So automatically, the first parameter you put is going to be corresponding to x, and the second one will correspond to y. But if you want to just specify, you can say x is equal to this and y equals to that. Then the arrangement won't matter in that case if you are being specific to the arguments. So arguments can be optional. You do not have to specify a value for them, depending on you are creating the functions. Argument can have a default value also, and you can use as many arguments as you like or as is feasible, depending on what you want to achieve with the function. So let's see the next slide. So here before we created a function called add%, and we a parameter, an argument called x. So x can be a vector of fractions. So what it does is it converts it to percentage and add the percentage sign to it, as you can see here. So you can pass values to a function by adding arguments to it. So a list of values can be passed to a function with the help of an argument list. So the add% function multiplies the numbers by 100. I'll talk about that. This is used when you want to convert like fractions to percentages. So we created the function like that in the previous class yesterday. And okay, I just created a percentage variable that has vector of fractions or decimals in this case. And I said, okay, do add% of percentage divided by 100. So obviously what is going to do is that normally add% does what? It multiply 100 by the argument of the add% and add the percentage sign to it. If I multiply 100 by percentage by 100, obviously I'm going to add percentage back. So it's just like I'm going to add percentage sign to the elements in the percentage variable. That's why you have 58.232%. And inside the function, I use the round function to round it into one decimal place. That's why you have just one decimal place here instead of 0.23. And you have 120.4, then with the percentage sign, and 33 with the percentage sign. Also, moving forward, adding like this one is like we want to add an extra argument called mult argument. So to add extra arguments, include them between the parentheses after the function keyword. So all arguments are separated by comma. So the code to add the mult argument is this. So we created the add% function again. Then we said, okay, take an argument x and an argument mult. Then inside the body of the function, you can see I have a curly bracket. Inside the curly brackets, you have what operation you want that function to do. So I say I want to create a variable called percent, and that will be equals to it should round x times mod. So whatever value I generate with this operation, round it up to 1 decimal place. So and now I'm now saying, okay, paste this result, which is percent, and append the percentage sign to it, separate it by an empty string. So, so we have been able to um, change the content of the add percent function here. So, so this function is going to take two parameters, say x and the mod function. So let's see. So now, let's go to the next slide. Okay, they didn't use this in the next slide. So also we can also add default value to the add percent function. You can add a default value to the add percent function. So what that means is that if I have a default value in my function, let's say I have an argument y, and I gave it a default value 10. So if I don't specify the argument for that value y, it won't bring up an error. But if you just take 10 and use that value 10 in my function to perform the operation, unless that y is not being used in the body of my function, unless I didn't use that y at all. But if you use that y and you didn't specify y, it's going to use the default value of that y. It's just like in your SQL, when you create a table and you say, okay, this table is going to take the date data type and specify a default value, say null. Say if that means if I want to do an insert on that table, but I don't specify an argument or a value for that particular column, it's just going to take null as the value of that particular in that column. So if I specify the default value to be 1, so anytime I insert with that column and I don't specify a value for it, so the value for that particular column is going to be 1. So the same thing with functioning. So here we are trying to do the add percent, specifying one argument. So it gave me an error saying that the mod parameter is missing. And why is that? Because when I created my new function here, it's based on two arguments, say x and mod. So if I should put one parameter here, it identifies this one as the first argument, say x. So it's expecting another argument, say mod, because in this body of my function, I need the two arguments to perform. So I used x and I used mod. So in the case of the function trying to perform this operation, we find out that this second argument is missing. So you want to drop an error and say error in x times mod, because we wanted to perform this operation, but it didn't find this second argument, and it said, okay, it's missing. So that is the way it is being structured, and virtually it's going to return that, because it's trying to say it doesn't understand what you're trying to do. So R has no way of knowing which number you want to multiply by x. You want to multiply x by, so it stops and tells you it needs more information. So after you perform, you have put your argument, it's just, it won't ask you anything like that. So it goes into the body of the function and say, okay, let's try. Let's what is what we have. I have an x times mod. So it was like mod. I don't know what mod is. So what's going on there? It just gave you an error that, oh, I think this guy is missing. I don't know what to do from there. All right, so moving on to the next slide. So this is the case where you are going to add the default value. So in this case, I created the function add percent again, and I said x, especially the argument x, then I put the mod parameter. But in this case, I said mod is equals to 100. So this way you specify default value. Now in this case now, if I should specify only one argument for the add percent function, and I then specify another argument, which is the mod argument, in this case, the function is going to use this default argument to perform the operation and won't drop an error. So moving forward to the next slide now, okay. So this one is saying, okay, using the dot argument. The dot argument saying they are optional parameters, optional arguments. It's saying that, okay, I can still accommodate more arguments, but in this case, they are optional. So as you can see, the body of the function, this parameter is used in this second statement here, say round. Round can take two parameters. So it can take the operation that you want to perform, and the second argument is the number of digits you want to round it up to. So the second argument, I put it as dot. It means that if I should call this function now, and I specify 3 arguments, so one will be x, the second one will be this, the third will be used in this dot, which is the optional part. And that part will be used here. So if I specify 3 as the third parameter here, it's going to use the 3 here and round this operation to 3 decimal places. So that is how you're going to use this dot parameter. So it's kind of optional here. You might not necessarily put it. So moving forward, so you can also use functions as arguments. You can also use function as arguments. You can create a function and also use function as even the argument of the function. So how you can pass a function itself as an argument. You can easily assign the complete code of the function to a new object. I think we already did that yesterday. So you can also assign the function code to an argument. So let's see how that works out in the next slide. You can see here, so you can use the round function inside the add percent function to round up numbers as shown below. So we use the round function as an argument in the add percent function. You can see it took x as an argument, mod a default value, an argument. Then I specified this as an argument again, the round function as an argument. So instead of me to use round, I just use fun because fun is now round, and I can put all of this. So I don't think this case is actually necessary, but it's just to say I can actually use it as an argument. So instead of me to say round, I just use this name I've assigned to the round function and just use it inside the argument. Okay. Now, using anonymous function. So using anonymous function. So anonymous function is a function without a name. Such type of functions can be used for one-liner code. So I think we can explain this. So in R, instead of giving a function name, add the code as an argument, as an anonymous function. So I don't need to try to create another function and put inside function, but I just add the code of that function and put as an argument in my function. So as you can see here, I said I want to use the add percent function, and the add percent takes what parameters? 3 parameters. The x, the mod parameter is now a default, right? You might not necessarily specify it. You're going to use it as 100. So here I applied profit. Profit is my x. The second parameter is supposed to be mod, but I didn't specify it. Then I specified the fun parameter. The fun is the round function, but I'm not saying that my fun, I don't want it to be round. I want it to be this particular thing. So I created another function inside the argument. Say this should now be the function of x round x all over sum of x times 100. So this is kind of using, you are trying to create a round function. So like you're creating a function inside a function. So it doesn't matter. It depends on what you actually want to achieve with that. So this is going to take an x argument and need to perform this operation on it. So it's just basically going to do what the round function is doing in here. So what the round function is doing in here.
Hi, Daniel, I have a question. Yes,
okay.
that slide, this slide, no.
Oh, This place.
This slide, yeah. So I don't know anything about R, and this is my first class for R. So I wanted to ask, and I'll be taking you back, but I hope it's fine. So when you do this FUN, are you saying that this FUN is going to calculate the profit for each of these values? That's this 2001,
Okay, this one.
1430. Yes.
Okay. So what it's going to do is that it's going to say, okay, it's going to take this profit as an argument.
So sorry, I think I didn't ask my question well. So is it going to replace X by 2001 and
yes,
then calculate
yes.
it, then replace by 1430, then calculate it and give this 17%, 12% like that? Is that what it means?
So yes, it's going to do this second
Okay.
operation here. This operation is here.
Okay.
So it's going to divide it by the sum, each of them by the sum of all of these and multiply by 100. So the last line, so we're going to come to this last line and just do this, just to add the percentage sign to it.
Thank you, I get.
Okay. So okay, here you are saying that you want to add a new argument, SUB, to control the subtraction factor in the function named calc. Which of the following commands of R will you use for this purpose? Now, in this case, this doesn't make sense because you can't write a function. You can't write a function like this. This is a calc greater than, no, that's not to assign the function. You can't say calc comma function. You don't write a function like this. I can't say calc greater than also. So it is calc now equals, like this way you assign then function parameter and put another parameter. Yeah. So this is the right way to write the function. So talking about scope of functions, you have internal, external, and internal. We are going to talk about this specifically in the next slide. So how does this work? Looking at this now, you have, let me open my VMware. Let me open it down so that you can. I don't really like, if I'm working it out, I don't really like to stress myself to open the VMware environment. But let me just try workstation.
I'm going to come to the office this week because I don't have anything installed for this class. So I'll come this week to the office. Yeah.
All right, no problem. It's been a while that you came to the office.
Yeah, because I've not been feeling okay, and I didn't and I was not sure the nature of my sickness, so it was better for me to stay home.
Okay.
Yeah.
All right, no problem. You are better now, right?
Yes, I am.
All right. So here what am I doing here? So this I think we created a function in here. So apparently what we are doing is this. If I create inside a function, any variable I create, it's like a local environment. So any variable I create inside my function is called a local variable, and any variable I create outside the function is called a global variable. So what do I mean by that? You can use a global variable inside the function, but you can't call a local variable outside its function. So what am I even saying in this case? Let me log in. So I can just use R Studio instead of having to, since I'm just using R, I can just use R Studio on my local system. So here, if you use a function, the function first creates a temporary local environment. This local environment is nested within the global environment. So the global environment is the environment outside the function. So which means that from that local environment, you can also access any object from the global environment. As soon as the function ends, the local environment is destroyed and not with all objects in it. So I can't access any object I create outside the local environment unless I assign it to an object. So what am I saying in essence? I think all of this is just gibberish. You might not really understand what I'm trying to say. So let's say, for example, now, I think I created something like this here. So look at this now. Can you see this screen? Can you see?
I can see your screen.
So here I created another percent function. Let me run it again. So let me run this guy again. You can see inside the I assigned percent to something, right? I said percent is equals to this. Now, normally, if this percent was created outside this function, I'll be able to call it. But if I should say percent now, so let me run percent. As you can see, it says percent not found, because this percent was created in the local environment of the function. Is a local variable, so I can't call it outside the function. So you can't do that. So that's the concept of global and local environment. But anything I create outside the function, I can access it. And in this local environment, I can access something in the global environment. So the global environment is the environment outside the function. So if I should create a function, say x is equals to 1 to, so this is going to create a sequence of 1 to 5, and I say I've created it already. You can see type x. You can see 1 to 5 down here. So if I create a function that's going to use this x, I'll be able to access this x. So if I say, okay, add 10. If I create a function, say add 10, now equals to function, say x, and I say, okay, this is now equals to, I don't want to add any parameters here. So inside the function, I want to say x plus 10. You know, I didn't put any arguments, and I'm calling a particular x that is outside the function. So let me run this for you. I've created the function. So let me now call add 10 for you now. Let me call add 10. So you can see that add 10 gave me this guy. I didn't put, let me put the bracket. So let me run it. You can see add 10 gave me this result without even specifying a parameter. Reason means that it was able to use the variable I used outside the environment, which is the global environment. So I was able to use the global variable inside the local environment, but I can't call a local variable in the global environment. Do you understand? Do you understand that? Hello? I don't know. Okay. So that is about. So using internal functions in programming, it is not considered a good practice to use global variables in a function. So reason means is that if I should get a function that uses a global variable, what if I should close my session and the object was gone and I want to run that function? It means I won't be able to run it because I don't have the variable. I don't have a variable. So your function is supposed to be dynamic. It's not supposed to be dependent on the variable outside the function. So it's not considered a good practice. So you can use functions to avoid dependency on objects in the global environment, which is what's discussed here. So on the main ideas of R is that the outcome of the function should not be dependent on only its arguments. So if you give the arguments the same values, you will always get the same result. So it should be dynamic, whereby I can put in anything. It's not like it should be specific to a particular object, like what I just did here, which is like the add 10 doesn't take any parameter and just uses the, the the guy outside my local environment like this. So it's just like a constant function. You cannot, if I put anything inside, it will even give you an error because unused arguments I didn't use, it was not defined to take any parameter, and the whole uh, body of the function is to operate on this guy. So moving forward, So to calculate at 50% efficiency, you can use the function shown in the following table. Let's look at this function. Say calculate.f. That's the name of the function we want to create. Okay, we want it to take three parameters, x and y, and the control parameter argument. So we now say we get another variable mean base to be a function of z, but it should be z minus mean of control. So this is going to do z minus mean of control. Then this guy, so control is from this guy. Now mean dot base is a function of x. Sorry, what am I saying? Mean base will now take a parameter x all over mean base y. So mean base takes one argument, right, which is z minus mean control. You write this very well, sure. Hello. Okay. Okay. Okay, yeah. So mean base is now a function of z, and we want it to perform this guy. Say z minus mean of control. So I'm now calling this mean base function inside again. Say mean base should take x. So what this is going to do is x minus mean of control, which is specified in here, all over y minus mean of control. So that's what I want my function to do. So it's going to return this operation finally. That's what I'm going to do. So the code to calculate the code for calculate.f function as shown in the table below. So I created two vectors, half, full, and nothing. Then I specified like this. So half here is going to be my x, full here is going to be my y, control is going to be this nothing. So what's going to do is, so it's I'm going to do mean base, which is going to take a function of z. I'm going to be z minus mean of nothing, z minus mean of nothing, but we don't know what z is yet. Okay, so it comes here. So mean base is going to do this. So what's going to be mean base of x? So it's going to use this function here. I'm going to do what's my x half. So it's going to do half, which is this parameter here, minus mean of control all over mean base of y, that is full minus mean of control. So that is going to give us this result in here. So we can just try and practice. That. So practically what we're going to do, let me get the vectors that we use for that practice. Say half is 2.23 and 3.23 and 1.48. So let me create the second vector. Say who is going to be combining 4.85, 4.95, 4.12. Then lastly, I'll create the vector nothing, which is going to be combined 0.14 and 0.16 and 0.56 and 0.16. And 1.8, not 1.6. So 1.8, yeah. So let me run this. So the calculate.f function. So let me do it. I won't use it, but I will tell you what is going to do. So calculate.f is being built using parameter x, comma y, comma control. We're going to take three parameters there. What's going to be inside the parameter? It's going to be inside the body. I'll create another function called me.base inside, just inside the function, and say it's going to take z as parameter.
Emmanuel, sorry.
Yep.
Your line 179. I thought it was x, y.
Yeah,
or
x, y.
control.
So I just do it. So main base is going to be another function inside this calculate.f function. And what does this main base going to do? It's going to take this parameter minus the mean of this third parameter, which is control. Then what is it going to be done? It's going to be done mean dot base of x minus mean dot base of y. So apparently this is what it's going to do. So mean dot base of x is going to do x minus mean of control, because mean dot base of x is the argument here. So it's going to be x minus mean of control, and x will have been provided in this calculate.f function. The mean dot base of y is going to do y minus mean of control. So let me run this line to create the calculate.f function. So if I want to use this function, I'll say calculate dot f, then I'll put three parameters, which is x, y, and control. So in this case, I'm putting r, and nothing as my parameter. So r, comma, 2, comma, nothing. Yeah. So let me run this line. What's happened? Error in mean of
The spelling of your nothing. This one where you are calling the function is single T, but where you defined it up is double T.
Oh, sorry. So let me put double T there. Thank you. So we have this result here. So I want to use this intuition here without using the calculate function. So to get the same result. So what it's actually doing in essence is half. So let me put inside parentheses half, which is this z that is here, minus the mean of control. And what's control in this case? Nothing. So that's NO. I'm using double T. NOTING. Sorry. Divided by, I'm sorry, is it divided by minus? Well, ID is minus divided by, I want to use divided by, let me create the function again. So let me run this line again. So it's going to give us this answer. So this is going to be divided by full minus mean of nothing. I'm using yeah, not double T. So if I should run this line now, so let me give this please. If I should run this line, it should give me the same result as what the calculate.f function gave us. So let's run it. As you can see, it gave us the same result. So apparently that is what the function is doing. It's just for us to understand the intuition behind it. So it's just that simple. Just that simple. So moving forward, talking about the mean, I think I've talked about what this guy actually did. So you really don't. I think you missed one part. I was talking about global and local environments. Did you see?
No, I understand it. Yeah,
Okay.
I saw it. I understand. I actually understand what
All right.
it means. Yeah. Thank you.
Yeah, you're welcome. So I think we already talked about this local. So this was is just trying to talk about the global and local environment. So which of the following is the core syntax for creating a function inside a function? So is this one correct? Let's check it. It says function one is equals to function into brackets function 2 comma, no, there is no function inside this function because this is the parameter for building a function. Function 2 is not a function, it's just an argument, it's just a parameter. So this is the body of the function, like this, starting from this brace. So, and there's no, we didn't call any function inside this place, so there's no function inside the function. So let's look at this second one. This second one, we say function 1 is equals to function into brackets. We put 2 arguments. Then inside the body of the function, we created another function. We use the function keyword. So this is an example of function inside the function. This one is not function inside the function because I said function 1 is equals to function, then put the argument. But then inside the body, I said function 2 into brackets. That doesn't make sense unless you are specifying the function keyword then into brackets. So this is an example of a function. So you have function 2 inside a function 1. That's why this is a function inside a function. Function 2 is inside function 1. All right. So the example of that is just the mean based function that we did. So this is a function, calculate.f function. Then we have the mean based function inside it. So this is an example of a function inside the function. Yeah. So moving to the next slide, which is the last slide for this session. Okay. So dispatching to a method. So functions actually have methods. So some function has some methods attached to it. So you will see some function performing a lot of things. For example, the print function. So the print function does a lot of things. The plot function also does a lot of things. So they have several methods, but the way they have been built is that if you just use them naturally, they'll just look for the right method to perform that operation.
Okay, I'm coming.
So they just look for the right method to perform that operation. So let's do, for example, if I should go here, I say print dot. So after the dot is the method. So print dot, these are the method we have by RNA, print dot date, print dot table. Print dot table is being unique to print tables. Print dot let's say print dot data dot frame. Print dot data dot frame is unique to printing data frame. So, but without specifying the method, we just use print into anything you put inside. You just find the exact method to actually perform the operation. So, for example, x here, I created a variable x. Oh no, I created a variable x. This x is a vector. If I should say print x, it's going to print it for me. But he didn't know the method he actually used to print addition. It just printed it for you. But if I should use a specific method, say print dot data dot frame, I should now say into bracket x. This is going to show up. It didn't show up an error. So it didn't give us anything, but it didn't show up an error. It said null. It said null because it didn't identify x as a data. Since it's a vector, if I want to use it a specific method, I can say, okay, print dot, I think I should be able to use print dot if I'm not able to see it, I can say, okay, print dot default. There's a particular method say print dot default. If I should print dot default of x, you should print it for me. So you don't necessarily have to go into using methods and all of that, but they have methods. They have methods, but if you don't specify the methods, what is just under at the back end is to just look for the right method to do whatever operation you want it to do. So that is the method. So finding methods behind the function. So look at this now. If I use print, is a function that takes one argument, say x. So it's used the method called print. But there are different methods attached to it. So the data frame dot vector and the likes of that. So the use method function. So the use method function is the central function in the generic function system of R. Function tells R to move along and look for a function that can deal with the type of object that is given as the argument of x. So as you can see here, suppose you have a data frame, you want to print we want to use the print function. So I will look up to the function called print.data.print and use that function to print the object you passed as an argument. But you will know at the back end by just using the print function to just print it. But this is what it actually is. Just find the right method to print the function. So here we created a data frame of two vectors. Say A is 1 to 2, B is 2 and 1. Then I convert to a data frame that I can use print the data frame to print that particular object. Since it's a data frame, it's going to return the result. So, but it's been specific to print data frames. So as I used earlier, I use print.default, which prints whatever you pass into it, the default print method. So just use the default method to print whatever parameter you pass to the print function. Okay. So if I use print.method for small.1 now, small.1 that we created here is a data frame, but if you look at in here, it printed the result as a list. So this way you are supposed to print a list. So it prints the data frame as a list. So if you use the default method, so the code for using default keyword is shown here, as you can see. So in which of the following forms will a list be printed in the R console in the row form? So it prints it in row form. So the first element in a row format like this, as you can see here, and second in the row form, compared to what we have here, whereby it's kind of column form, say 1, 2, 2, 1, but here in row form, as you can see. Okay, talking about packages. So the R program has inbuilt packages that you can use to perform tasks. You have a lot of packages. So if you want to, for example, when you first start out, several packages are loaded on your computer by default, but some packages you have to install them if you want to use them. So an example of when the search command is shown below. So if I do search, if I run the search command, it gives me all of the available packages in my current session. So let's say, for example, search. So I have all of this. I have all of this, but if you want to see the objects you have created in the environment, you can use the library ls command to see the objects you have created. You can see here I've created nothing, the object nothing, the object have, object y, x, bec. These are the objects I've created in this session. Calculate.f, it's also showing the function. So if you want to install packages, after using the install of packages, you can use the package menu in Windows. You can use the package menu. I think you can use this if you are doing you are using the RGUI. I don't know. Can you use it with this guy? So you can use this RGUI. So let me open the RGUI here. So this is my R graphical user interface. So here, so this is the RGUI. So if I go to packages, load packages, it's still loading. So if I want to load in install packages. So you can see it got this option like maybe the kind of package I want to like load or some stuff. You give me options here, so I can just do that. So as you can see in this slide, so you have cancel now. So it just gives you the option of packages you can load into your environment. So that's you see RGUI. So you can choose the ones you require. Once you have selected the package you require, click OK button, and the package will be downloaded and installed directly into R. You can perform the following steps to install packages on Linux, but if you are using obviously if you are using Windows, you can use the function install.packages. So let me go to the next step. Yeah, you can use this install.packages, then inside the bracket you specify the package you want to install. So this guy was trying to install the package AD4. Then after it has been installed, you are going to see something like this. So installing packages, and it is done. Then the download packages are in. Then if you want to load it, you can use the library function to load it into the environment. So you say, I think I should be able to say that in the next slide. So as you can see here, to load the package in R, you just specify library into bracket, the name of the package, then you load it. So probably if you are done using the package and you want to unload it, you can use the detach command to do that. And that's not only what you can use the detach command to do. I will just tell what you use the detach command to do. So which of the following commands in R you will use to see the available packages? Search command. So you can use this attach, there is detach. Attach. So if I want to use attach, I will explain with a data frame, for example. Are you still there? So let me see whether I have the iris data set. Iris. Okay, yeah, I have it. So suppose I want to call this particular column, this is a data frame. So suppose I want to call this particular column or this particular one, say species. If I want to call a single column, I can use the dollar sign. So how do I use that? I will specify the data, then I'll put the dollar sign, then it's going to count all of this. I'll just type after the dollar sign the name of the particular column I want to call, say species. Then it returns it. But naturally, I can't just type species and call it. Instead of, I have to reference the data it belongs to. So if I should run this line, say species, it tells me object not found. But if I want to do this without me having to call the iris or to reference the iris data set, I can use the attach command. I will say attach iris. So if I should do attach iris, it's like it's loosens up the iris data set, whereby I can call the columns without having to reference the data set. If I should run this command now, then I will be able to run this command and call the iris column. So if I should call the iris, you can see, sorry, species. If I call species now, I'll be able to see what is inside the species column. Then if I'm done, I can detach the iris data set. And if I do this operation again, I'll be able to call species to say species not found. Okay, I think we got to the end of this particular session. So let me see. I think there's a lab attached to this guy so that if you practice one or two things with it before we go to the next session. So functions in R. So let me look at the lab functions function. Okay, this. So I'll just copy this guy. So it's not much of the thing that we have discussed most of the things here. We want to discuss here. So let me just copy this guy and go to the out. Let me just and paste. All right. So from here, we want to create a vector that has these names. So let me run this line. So I've attached it to this variable called person's name. And I want to also create a vector called spending. It's going to have these values. So let me run this line also. Then I want to create a vector called profits, which is going to have these values. Now, I want to now create another variable called bonus. Bonus is going to be profits minus spending. So as you can see here, so if I should run this, then I have the variable called bonus. Now, bonus details. I'm not saying bonus detail is now equals to as dot data frame. That is, I want the resulting operations here to be a data frame, but I want to column bind this particular variable, say person's names, and and bonus. So column bind means like I want to attach them side by side. So it means that I want to get this guy person's names and this bonus vector. I want to attach them side by side using the cbind function, and I want to convert it to a data frame. So let's run this line. Okay, so let's print the bonus details that we have. So this is what we have. This is what the data frame looks like. This particular, this is a column person's name, this is a column bonus. Then this is the row names, like the index. So now we have the source function. The source function is like, okay, we have created a script called carbonus.app. A script is just, I think you understand the concept of script. Okay, let's say I want to perform a particular operation. I type it in this editor. So then I will save it as .alpha. Automatically, if I put it in this editor, it saves as .alpha. But I can go to Notepad, I can go to WordPad, I can go to Word and type whatever operations I want to that particular code to perform, and I save it as .alpha, and I can run it on R. So if I don't want to load the script, I don't want to open the script here, but I just want to source it, that I want to run the content in that script. I can use the source function, or I can use this source button here. So there's a script that has already been created in the dataset folder in this lab called carbonus.app. So let me go to file here, and this is dataset. Let me. So I think I should be able to see it here. If it's not here, then I won't be able to source it. According to what is here, it's inside this particular this folder dataset, and I'm inside this folder. I can't find a function called source carbonus.app. It's not here, so I won't be able to do this operation. It's going to show up an error. Okay, it's going to show up an error. Let me see whether I have a script that I've created. So let's say I want to source this guy, testing.app. So it's inside the home directory. So inside the dataset. So I have testing.app. What's the name again? Let me check. Testing.app. So I want to source it. I'll just remove this guy and just specify testing.app. So I want to run the codes inside the script. I'll just say source this guy. So if I should run this guy now, you can see this is the result. So inside the script, I said it should do something for me, and it should print that stuff. So this is actually the operation that is inside the script. So that's just about sourcing script. Are you still there?
Yeah, I'm here.
Okay. So now we have a calculate bonus function. We want to create a calculate bonus function. So how do I do this? So I say calculate bonus is equals to function into brackets. It's not taking any parameter, but I'm using a variable in the global environment. You know, I've already created this person's name. So I now said, okay, person's name is equals to this. Okay, maybe I'm creating that another time again. Plus spending, which is this, plus profits, which is this, plus bonus, which is equals to profit minus spending plus bonus detail, which is equals to as data frame of this guy. Then return bonus details. Okay, so just like you are trying to transform a script to a function, probably the calculate bonus function was used to So this stuff that we just did here, this operation we perform from this place. So from this person's name to this place is what is inside that function. So we just pass it as a function. Say, okay, let this function perform all of this. Let it give, create a vector, call it as person's name, create a spending variable as this vector, create a profits variable as this, create a bonus variable as this, create a bonus and create a bonus details as dot data frame and C bind the person's name and the bonus details. Then I want it to return the bonus details. So you can see it after I've called the function. Okay. So let me run this calculate bonus function. It gave me an error. Not happening. Said error in scan file, blah 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 blah. Okay, I think there's something wrong with it. Let me just make it simpler so that we'll be able to see what's inside. So I'll remove this. So first of all, I'll make this be inside another line. Okay, then I would remove this plus sign, and so I should go to another line. Then remove this and make it go to another line. Then remove this, make it go to another line. Then remove this, make it go to another line. Yeah. Then this one should be okay. Then remove this, make it go to another line. Then this one should be the final line, like the end of the function. Okay. So the function does not take any parameter. So we are assigning person's name to this vector, this one to this vector, this one to this vector, this one to this. This one should be profit minus spending, and this one should convert to a data frame and first of all combine this particular vector with this bonus and convert it to a data frame. Then return this guy. That is, I want to see the result after I've called this function. So let me run it now again. Okay, it has been created. So let me now run this line. So let me call the function now. So you can see it's empty because it doesn't take any parameters. So I can just run. So you can see it gave us the bonus details, which was created as a data frame. And it was just the same thing that we did up here. It's just that we did it one by one. But this we are creating as a function. Okay. You can also use function as object. So this calculate bonus that we created, which is this function, I can assign it to another variable. So I'm saying calculate bonus is equals to this variable, say m bonus card. So if by the time I perform this operation, if I perform this operation already, it means that what this guy can do, this guy can now do the same thing. So I can say, okay, m bonus card, then call the function, I put brackets, then if I should run this, perform the same thing as what that other guy was doing because I already assigned it. So I think that's just it. That's just it. So here we are trying to say that we can add default value to our function. So I created a function called multiply x, say is equals to function which takes two arguments x and y, but my y here is default. That is, if I don't specify my y, it's going to take my y to be 10. But this is what I want it to do. I want it to do x times y. You can see I didn't put a brace, but it's still understandable. Like, okay, after this function, I want it to do this. I'll just put a space and put whatever operation I want it to do. I can do that, but I mean, I actually like putting brace so that it will be more readable and more to make more sense. Yeah. So if I show on this function has been created, then if I say multiply x and put 3, it's going to understand 3 as my first argument, which is x. My second argument is optional because it has a default value. If I don't specify it, it's going to take it as 10. Then it's going to do 3 times 10 for me, which is going to give me 30, as you can see here. But if I should put second argument, say, comma 20, it's going to do 3 times 20 instead of 3 times 10. As you can see, 3 times 20 is 60. it can take a vector too. So it's going to multiply 10 by this vector, and I have 100, 200, 300. But if I specify the second argument, say 5, I'm going to multiply it by 5 instead of by 10. As you can see, 5 times 10, 50, 5 times 20, 100, and the likes. Okay. Also, I can add dot, dot, dot. I think you were here when I was explaining adding dot, dot, dot to the function. It's like optional parameter that you can put inside the function. Depending on what you want to build, you can, so that you can take some kind of optional parameter. So this one is optional. If you don't put it, so this, you have first parameter, second parameter which has a default value, then the third parameter which is actually optional. You might not necessarily put it. So you can see the dot 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 was used in the round function here, which means that if I should specify a third parameter, it's going to be used inside this round function. So what it's going to do is it's going to take it to, maybe if I specify 3 as the third parameter, 3 as the second parameter inside the round function means I want to round it, this particular operation, to 3 decimal places. Okay, that's just. So let's go to the next session. So here we're talking about the statistics in R. Okay. So here we are going to use, so today's objectives in this session is how to summarize data samples, use cumulative statistics, perform summary statistics for data frames, matrices, and lists, create contingency tables, perform cost tabulation, and test cost table objects. We have first that in this session. Let's see how far we can go here. What are the ways we can use to summarize our data, summary statistics, tabulation method, and the graphical method. So we are going to see how to perform all of this. So summary commands. An essential starting point with any set of data is to get an overview of what we are dealing with. So we can use the summary command to like say, okay, the first 5 numbers summary together with the mean. To get the first 5 number, the 5 number summary is the minimum, the first quarter, the second quarter, which is like the median, the third quarter, and the maximum. Yeah. So you might start by using the ls command in R to see what name objects you have with you. You can type the name of one of the objects to view its contents. You can use the xcr command to show the structure of the data you are dealing with, and the summary command is designed to give you a quick statistics summary of data objects. That is the 5 number summary and your together with the mean. So we have this name command that you can use. So names automatically just gives you like the column name of your data sets. Like that's actually what it does for you. So what's on a list of data frame objects gets or sets names of columns of a data frame or columns of a list. So what the names works on matrices of data frame objects gives you like the whole names of the columns of the matrices of data frames. I think works with these guys. So column names works with columns. Dim names works with like matrix or data frame objects. So dim names is that you are giving a name for both the rows and the columns at the same time. We talk about the ls command. Okay. So summarizing sample. So in case of repeated measurements of sample, you usually want to summarize data by showing measures like average, like maximum, minimum, the mean, that's the average, the median. So summary statistics command for vectors. You have commands for single value results, command for multiple value results. So command for single value results are like your mean, your average, your maximum, minimum. Commands for multiple value results like your row sums, your row means, your summary statistics. I think I'm going to see that in better in the next slide. So summary commands for single value results. You can see maximum, length, minimum, sum, mean, median, and so this all this gives you a single value. So it's like, okay, I want to see the maximum age of a particular column. It's just one result, minimum one result. So how about multiple results? Then we have your summary command, your counter. This is going to give you a five numbers. Yeah. Like log of data sets. This is going to give you the log of each value. I don't know whether it's kind of so these are the ones that give you like multiple results compared to your single value result. So here I say we have the sample vector data one, which holds the following values. So which of the following commands can be used to find the 25% quartile? So this is the function you use. You use the quantile function, specify the data one. So this is the data, you put 0.25, which means 25% quartile. So also we have cumulative statistics. You have the simple cumulative statistics and the complex cumulative commands. We are going to see that those we have in the next slides, like the column sum, the cum sum, the cum min, the cum prod. So like all of this stuff. Cum sum, that's the cumulative sum. Cum max, cumulative max, the cum min and the cum prod. We're going to see how this guy works out. Let me just go to my house. So I'll use a simple illustration. So let me use this guy for example. We have a variable called first. So let me type first. This is what's inside 26.6 is 34.4. So say peradventure I want to see the maximum number here. I can use the max function and say max of first. So the maximum is this 34.9. Okay, now let's talk about the cumulative statistics. So if I want to say cum sum, I can say cum sum of first. What does just cumulative statistics? So start from the first guy, then add this to give me this, then add this to give me this in that regard. So if I want to do cum min, this is how cum min works. The first guy is going to be the minimum at first. So at first, this is the minimum. So it gives you this. Now it checks between this and this, which is the minimum. It's still this guy, so it still repeats it. Now between this and this, which is the minimum now, it is now this guy. So this is now the new minimum. So that's why this one comes up with cum min. For if I'm doing cum max, the first guy is going to be the maximum at first. So the first guy is the maximum, which is this guy. That's why you have this. Then it compares this and this. Which one is the maximum now? It's this. That's why you have this. Then it now checks between this guy and this guy. Which one is bigger? It's still this guy. So it still does this as the maximum. The cum prod, like it does it like multiplication compared to the cum sum. Okay. They have complex cumulative commands like using the sec along command, using the sec command. The sec underscore along is kind of the same thing as the sec, then putting in brackets along. So I don't really know how this is actually a complex cumulative command anyways, but because it's very basic. It's really very basic. I don't know how it's so I don't know why it's actually. Timothy, you want to say something?
No.
Your hand is raised. That's asking.
Sorry, I mistakenly pressed it.
So okay. So this complex cumulative command, I don't know how it is complex. So I don't know how it's actually complex, but it might be useful when you want to do something like a moving average. It can be useful. It can be useful. So why do I say it can be useful? I will tell you why I say it can be useful. So and then suppose you have the salary list of 100 employees. Which of the following functions should you use to find the minimum salary, maximum salary, and the interval of salary? So he said you can use the sec command. So you can use the sec command. So what that means is that I can see, if you see this guy now, okay, let me see the next slide. So let's say, okay, let me use my, yeah. So let me use this guy. If I say sec of first, for example, this doesn't really make sense. Now, if I say sec of this, you can see it gave me 1, 2, 3. It gave me 1, 2, 3. So 1, 2, 3 means it just gives me a vector having the length of that uh, of that argument. So this first vector has 3 elements: 1, 2, 3. So it just creates a sequence for me in that regard. Even if I should put sec underscore along, if I say sec underscore along, I still have the same thing. There's a function called sec. I'm still sec underscore length. Generate a class sequence. Okay. Standard. Okay. So this is what is actually taken. So I don't know how this is complex, and I don't know how this I say sequence suppose you have a salary list of 100 employees, which of the following functions should you use to find the minimum salary, the maximum, and the interval of salary? I don't know how this is going to help me solve that problem. So hold on. So underscore alarm. I don't know how this actually. So the reason I said this can help you with moving average is that okay, if I want to find the moving average of this guy now, I can just say first divided by sec along first. So this is the moving average. So first of all, at first the average is this. So by the time I move to this guy, it's going to do this plus this divided by 2, which is going to give me this guy. Is that right? It actually no, no. Is that actually right? I don't think that's what it did. I don't think that's what it did. So though it can help you with moving average. So what do I mean by that? It's going to do I want it to do this divided by this and it's going to do this. Then I want it to do this. Okay, sorry, it shouldn't work this way. So the way I'm supposed to do it is cum sum. So cum sum of this divided by sec. Yeah, this is what I'm going to do. So this gives you the moving average. First of all, it does this all over 1, which is this. Then this plus this now, all over 2, which is this. Then the 3 of them add together divided by 3, which is this. Yeah. Do we understand what I just did? Hello, do we understand? Am I the only one? Am I the only one here? Oh, okay. I think Similarly, Dasca network. So moving forward, you can also use all these summing statistics like single value, single results, summing statistics, even multiple results summing statistics for data frames. You can use max, you can use mean, you can use sum. Max, mean, and sum are single value. So this returns the sum of the entire data frame. This 5 norm gives you the say return the total summary values for the entire data frame. So let's see, I'm using 5 norm for that guy. Let me see. Let me create a vector to BEC. I think there's a vector called BEC. Oh, I removed it already. If you now create a vector called BEC, say 2, 3, 4, 1, 2, 3, 4, 3, 5, 8, 4, 7. Okay. I didn't put the comma here. Okay, so 5 now. 5 now. Save this. So you can see here, it gives you the 5 number summary, the minimum, the maximum, the first quarter, the third quarter, and the second quarter, which is the median. So it gives you the 5 number summary. This is a multiple value statistic. You can also do, let me see, I think it should be, let me see whether I can use the summary command with vectors. So the same thing as you can see. So this, the 5 number summary is going to be included in this summary command, which is the minimum 1, which is the same as what you have here. The first quarter 2.5, which is the same as what you have here. The second quarter median, which is what you have here, which is 4.0. The third quarter 4.5, which is what you have here. The maximum 8, which is what you have here. But what you just be included in the summary command is the mean, which is 3.9. How different between 5 number summary and summary command. You can use the quantile function. Quantile. So if I want to find the quantile of BEC, so let's say I'm interested in the second quarter or the third quarter. If I'm interested in the second quarter, it's 0.5. So I need 0.50 or 0.5. So this is going to give me the median. So as you can see here, you have 4, which is the same as the median. This same as what I have here, which is the median, which is the second quarter. So if I want the third quarter, that will be 0.75. That's 4.5, which is the same as the third quarter I have here, 4.5. So if I want to generate all of the 5 number summary, then I can put in combined, say 0, which is going to be the first quarter, the minimum. The second quarter is going to be 0.25. The second quarter will be 0.5. The third quarter is 0.75. Then the maximum is going to be 1. So this is going to give me the 5 number summary. As you can see here, minimum, second quarter, median, which is first quarter, median, which is the second quarter, third quarter, which is this, and the maximum, which is this. This is the same as what you have here as the 5 number summary. All right. So I think we have come to the end of this slide. Moving on to the next slide. Do you have any questions so far? Hi, Mary. How are you doing? Oh, wow. So we have some special summary commands here. You have the row summary, then you have the column summary. So you have the row means, the row sums, you have column sums, you have the column means. So what this one does is it gives you the mean on a row level. So this most likely works with matrices. So if you are doing vectors, so if you are doing it works with matrices most of the time. Because you can't work with data frame on a row level. So let's say you have a data frame. The data frame has different data type for different columns. So all the columns in the data frame might not have the same data type. So if the data type is not numeric, there's no way you can find the row means on a row level. Since it's doing it on a row level, it's doing it across all columns. And all the columns might not necessarily have numeric values as so it works best with matrices. So, but if you are doing column sum, then you should be able to do work with data frames in this regard. So on the depending on the data type of that particular data frame. So this does this the statistics on a row level, and this does it on a column level. So let's see. So there are two summary commands used for manipulating rows, row means and row sums. And the example of using this command is shown in the following table. So I think I have this guy. I think this is going to be a table or I think this is going to be a table. So I'm doing row means of FW. So it's giving the mean as per all these values. Now row sums gives me this summary. If you compare the two, I think this guy has two rows. This guy has two rows because 11 divided by 2 is going to be 55. 20 divided by 2 is 14. 20 divided by 2 is 10. 11 divided by 2 is this. This divided by 2 is this. This divided by 2 is this too. It has two rows. It's something that you can just it's intuitive now. You can just guess from this place because this is uh, this guy is times 2 of this guy. So you can do column means it's going to do on a column level. We're going to do on a column level. So let's see, for example, I think I have I think maybe I still have a function yeah, I think I have a matrix. I don't have it though. I think I have it. I don't think I have it again. There's a variable called mass that I created before. Let me do it again. See matrix. So using the matrix function. So I want to create a matrix from a vector of 1 to 25. Then I want the number of rows to be equals to 5. Okay. I want you to do it by no, I don't want to do it by row. So let me run this. Okay, I've created that matrix. Let me call it MATR. So this is my matrix. I wanted to create 1 to 25. Then I created 1 to 15. So if I want to do the row sum on a row level like this, I'm going to use the row sum function to specify the matrix. So row sums, I'll say row sums MATR. Can see the value I have there. It added all of this to give me 18, added this to give me 21, added this to give me 24, added this to give me 27, and finally this to give me 30. I can also use call sum, which is going to do it on the column level. On the column level, I'm going to have 3 results in that because I have 3 columns here. And I can do row means and column means, doesn't matter. So let's say I want to do code. So let me see whether I can do this. Code means of so as you can see here, I can do it for a data frame iris. So I excluded the 5th column because it's a categorical variable. So these are the average of sepal lengths, sepal width, petal length, and petal width. So let me use row means also. Let me just copy this. So let me copy this. and put it here now. And change this one to row. So you can see this is what I have on a row level. And this could only work because the four columns I was calling, now I excluded 5. All the columns I'm calling are of the same data type. That's why this is possible. That's why this is possible. So it's fine the row means on a row level. But if if a particular column there is not a numerical variable, then it's going to drop an error. So for example, let me remove this particular guy. Say, okay, I want to do for everything. The column means for everything. So let's go. We can see error X must be numeric. So it means it's telling me that there's a particular column there that is not a numeric variable, and that is the species column. That's why I have this error. So if we check the head of Iris data set, so it show up an error because of this column called species, because this guy is not numeric. All right. So okay, I think the value is back down. So that's how it works. We have the apply command, and this is also very essential too. So it's also very essential. So the apply command enables applying a function to the rows or column of a matrix. In some cases, row sums and row means and might not be sufficient enough sometimes. So you might want to apply some other function that are not all of these aggregate functions. That I want to use it on a particular column or row wise. So the apply is going to apply that particular function to where you want to apply, maybe on a row level or on a column level. So let's say, for example, so let's say, for example, I want this guy. So let me call that matrix data set. Oh, no, MATR. So this is guy. And I want to apply on it. So what do I want to apply? I want to apply on this matrix data set, matrix object. If I specify 1, it means I want to do it on a row level. Then specify 2, that's a margin. I want to do it on a column level. So let's say I want to do it on a row level. So I'm putting 1. Then I want to say, okay, so I want to say on this particular row, do something for me. So that is going to be the third parameter, which is fun. So margin command uses either 1 or 2, where 1 is assigned to rows and 2 is assigned for columns. So you can place the form part with your command, not necessarily inbuilt command. So the function you want to apply. So you want you also can add the additional instruction, say na.rm equals true. This one means remove the null values that I have in my data sets. So apply to the true. I don't want to apply this guy in this case. So this one is say apply on this particular object fw on row wise. That's why this margin, this one is saying. Then I want you to apply the mean. So give me the mean for each row, but remove what's it called? No value. So remove no value. So if I want to do it for this guy, so I can say, okay, on each row, give me the sum. So which I have here. And that is the same thing as the col sum, or sorry, the row sum that I did here. You see that the row sum that I did here is also the same thing that I have here as the apply command. But you might say, okay, that is not what I want it to do. Okay, I don't want it to do that. I don't want it to do that. I want it to find the mean. I can put the mean here, then it still just finds the mean for you in that case. Or let's say, okay, I don't want it to do that. I want it to do, okay, perform a particular task for me. So I can say function, I want it to do function of x, and do x squared for me. And do x squared for me. I think I should be able to do x is back. Let's see how this works out. So as you can see here, it takes each row and multiply it and take the square of it. So the first row, so let me call the matrix object for you. So it takes the first row, the first row, 1, 6, 11. It applies what square to it. That's why you have 1, 36, 21 as a result here. It takes the second guy, take the square of it, and apply it like this. So the function is not specific. So it depends on what you want to achieve. As you can see here, it says you can replace the fun part with your command. You can use any kind of function. Do you understand? Do you understand? Do you understand before we move on to the next slide?
So I wasn't paying attention. Just go to the next slide.
This is what I did. I hope do you understand this line of code?
Yeah.
Okay. All right. So, okay, moving forward. Instead of following is the correct format to use the apply function. Yeah. The x, then the margin, and the function, then the optional parameter. Let's this. So, summary statistics for matrix objects. Matrix appears like a data frame, but it has rows and columns. So you have rows names and column names depending on the way you customize your matrix. So data in matrix of the data is a single vector, but split into rows and columns. So this, for example, you have a bed matrix with these column names and these row names. So we can say, okay, give me the mean of beds for the second column. Here, give me the mean of bed for the second row corresponding to all the column. This one is saying give me the mean of bed corresponding to the second column but all the rows. So this is just indexing in the normal indexing in matrix vectors and yeah. So you cannot extract part of a matrix using the $sign. So let me try to explain the indexing again. So as I have this matrix, for example, which is the whole of this. Suppose I just need this part, so which is row 3, row 4, row 5, and I need all the columns corresponding. So I need 3, 8, 13, 4, 9, 14, 5, 10, 15. Then I can do this. I can say MATR, which is the object, and I put a square bracket, and I put a comma. Then to the left of the comma is going to be what are the rows that I need to call. I just need to call 3 to 5, so I can do this. Then if I don't specify anything yet, it means I want all the columns to be returned. So this is going to return all the columns corresponding to the third, fourth, and fifth row. So that's going to give me 3, 8, 13, 4, 9, 14, and this. But if you run this guy, you can see what I have. But peradventure, you are not calling the rows in a particular order. Say, okay, I want 1, 2, and 5, and I don't want 3 and 4. So you cannot write it this way. So you can just say, okay, I'll put inside a combine function, say 1, 2, and 5. So I want to give me the rows 1, 2, and 5. but maybe I just need the first and the third column correspondingly. I just put inside combine function say 1, 3. So give me both 1, 2, and 5 corresponding to column 1 and 3, then I will have this result. So this giving row 1, 2, and 5 corresponding to column 1 and column 3. So corresponding to this, so give me 1, 11, 2, 12, 5, 15, as you can see here. All right, that is indexing. It's very basic. You can just read more about it. So this is applying using the apply command on the third matrix, doing it on the column level. Then I need the median. So that's just basic. Okay. Okay, then this is just saying that okay, after we've done the apply command, just give me the first two values. Just give me the first two values. This one saying give me the first, second, and fourth. This one saying okay, give me 1, 2, and Robin. This might not really make sense. It might give you any. So I'm saying give me bed and Robin. It depends what the bed matches looks like. So I think maybe this guy can be the values. Let me look at the bed matches again. So this is the bed matches. So I'm doing this on a row level. So on a row level, black bed and Robin. You have black bed and you have Robin. So it's going to do that based on black bed and Robin. So it's going to apply this again for black bed and Robin. Okay. I think that's basic. Okay. So consider the following data matrix. This is a matrix. Now apply the following command on this matrix. So this is going to do apply on this matrix on a row level like this. Then we're going to find the median. So for this row, the median is going to be 67 because by the time we are reading ascending order, 67 is going to be the guy in the middle. For this row, it's going to be 72. Then we're going to give it so 67 corresponds to Smith, 72 corresponds to Anderson, 82 corresponds to Clark, and but here I said give me for just the first and the third value. So this is going to give you just the first guy, which is 67, and the third guy, which is 82. Yeah. So it's just going to be the first and third subject correspondingly. Yeah. So okay. So this is summary statistics on for a list. So you have a list here called grass.l. You can use summary statistics on a list. You can use the length function to get the number of elements you have in that list. Then you can find the mean corresponding to a particular element, particularly. So let me create a list, for example. So let me create a list in that regard. So I want to create a list as what I have in my instruction there. So this is list, I will say mo is equals to say 1, maybe 10, 12, 11, 15, 14, 18. And I'll create another element called mo, which is equals to combine 13, 10, 7, 12. Okay, so let me call class.tab. So this is the list you have. So this is the first guy, and this is the second guy. Now, I might want to subset this guy. So okay, maybe I just need the first guy, which is this guy. I can call it using the ampersand sign, say ampersand move. So I just need the first element, which is this first guy. If I need the second guy, I can ampersand it and say dollar sign on move. Then I have the second guy. And that means I can also do something like this. Say, okay, probably I don't know the name of the elements, so I just want to call it based on the index. If I need the first guy, I'll use a double square bracket and put the index. Say I need the first guy. If I should call this, it gives me the first guy, which is the move. Then if I want to call the second guy, I can say 2, give me the second guy. But if I want to go deep dive, I want to deep dive into the guy, I can say, okay, after he gave me the second guy, I need just his first, third, and fourth element in the second guy. So I can put another bracket here and I specify combine to give me the first, second, and fourth elements. That will give me 13, 7, and 12 correspondingly. Okay, sorry, 13, 10, and 12, first, second, and fourth. So that's basically how you can subset a list. So you can use some statistics on this anyway. So let's say I want to mean, let's try this. Where it's going to work out. So class yeah, give me error because I said argument is not numeric or logical, returning NA. So the reason is that it's not understanding what I'm trying to do because you have several elements in that guide. Unless I want to do it on based on a particular element. So let's say I want to do this for the first guide. I can do this. So this is the mean of the first guy, which is the move. If I want to find the mean of the second guy, I can do this. But if I want to do, okay, I want to do the apply function, but you can use the L apply with a list instead of the normal apply. So I want to say L apply, then I'll specify the guy I want to use, say class dot L. Then I can say, okay, maybe I think we're going to get the anyways. So as you can see here, if I say length of grass, it's going to give me the number of elements I have there, like number of objects like inside the list. So in this guy, I have more and more, so that guy gave me 2 as a result here. So here I'm saying give me the mean of the more guy inside the list and give me the maximum of the more guy inside the list. So let's look at how to use the L apply command. So you can see here using the L apply command, which can be used for a list, which also denotes list apply. So L apply on grass, then specify the function I want to apply on it mean. Then I can say any dot remove is equal to true if there's a number in the list. So this one is fine. Give me the mean for each element in that list, as you can see here. So let us try and run what we have here. So if I should run this now, it gave me the mean for each element in that list in this format. So this is the mean of the move and this is the mean of the move. So you can use L apply in that regard. All right. We have already almost exhausted our time. So that is how you can use L apply. Also, say let's add some extra instructions to the command to ensure that the NA items are removed before the main command is applied. So the result is in the form of a list similar to the original object. So to produce a better result in the kind of tabular format, instead of having it in this format, you can see the S apply. S apply class.L, give me the main, then NA does remove because you have this result in this kind of like table format instead of the list format as you have it as L apply here. Then I said run the following command. Let's apply this and we have this. Which of the following statement is correct for this command? The resulting output is in the form of a matrix. as you can see, this guy, this also happens in the form of a list. It's L applied and then give this form of a list. So this also happens in the form of a contingency table. It's not in form of contingency table. So if it's in form of a contingency table, you are going to have like rows and columns corresponding and having values like kind of a pivot table. So contingency table is kind of a pivot table, a pivot table in this. So talking about contingency table, you use the table command to create contingency table. Though you can create some complex contingency table using the F table function, but you're going to start with the table function to create contingency table. So they are mostly used with categorical variables. So they are mostly used with categorical variables, not not basically numerical variables. So let's look at it. Just form the kind of constellation. You can use it for confusion matrix and less of that. So let's say you want to see you have a data frame. So data frame A, so the table column A has the gender, or let's say gender, yes, say gender. Then the column B has type of cars. So let's say you did a survey that makes responded to say I like this kind of car, Toyota. Another person said I like this kind of car, Honda. Another person said, and their gender was collected. So and I want to see who are the male and females that like some specific cars. Let's say you just specify like 5 models of cars. Let's say it's Toyota, Honda, Benz, BMW, and Mitsubishi, for example. So you'll be able to see the number of males that like Toyota, the number of males that like Honda, the number of males that like Mitsubishi, the number of males that are corresponding to females too. So in that way, you'll be able to create a kind of contingency table. So which is a form of pivot table, which kind of summarize the data in some way that you'll be able to see, who are the people that have something in common. So that is what the table command does for you. Use the table command to create consistency table. That's what I was speaking about. So for example, you have this data, and the table command also helps you to summarize your data in a way. So if you have this data, for example, the data 2, which is a vector of numbers. So if I should just say table of data 2, what it does for me is that it gives me the number of times a particular data point appear in this. So it's going to do for 3, for example. How many times does 3 appear? 3 times. For 2, how many times does 2 appear? Once. For the 4, how many times does it appear? So it's kind of like summarize your data set in this way too. So if you want to do it for a single column, this way it does the summary for you. It just gives you the number of times it appears. So if you have a column called gender, I want to know how many male and how many female corresponded to this particular survey. Then you can use this table of that particular column called gender. So it's going to give you the summary. So for male, you have 50 males, you have 150 females. So that's when if you are using one particular column. But if you are using 2 columns in this case, then you have a contingency table or a pivot table in that regard. So in our next class, we're going to continue from the third slide and the fourth slide. So we'll be able to finish this physics statistics in our next class. That will be next week. I think I'm kind of slow with this class, but you just have to take it step by step, sure. Yeah. So I think that will be all for today. Is there any question at all as able to have been taught so far? Hello, Maybe I've not heard from you since we started this class. I've not said anything. Hello. Wow. I don't think anybody's in this class again.
Hello, Emmanuel.